Hello, my name is Mr. Asprey, and this is my Edexcel exam series where I split up all the topics in the IGCSE and I do videos on those topics. You can download the PDF of this document in my Google Drive, so do that, do the questions, check your answers, watch the videos, happy days. This is probability 2, so we're looking at tree diagrams, and it's rather formulaic tree diagrams. These ones are independent because packet A does not affect packet B. And packet A, there are 7 out of 12 which are sunflower, which means 5 are going to not be sunflower out of 12. And then packet B, like I said, is independent of packet A, so it's not. Packet A won't have any effect on packet B. So whether you get a sunflower or not, it doesn't make a difference. The chance of you getting a sunflower from B is 8 out of 15, and again it doesn't make a difference what happened in pack A, so it's going to be the same, and therefore there are 7 which are not sunflower, so 7 out of 15 for not sunflower. Okay, and now it says calculate the probability that they will take 2 sunflower seeds. Well, here's the trick. If we want to work out the probability of something happening, then you need to multiply down the branch. So if I want to find both sunflowers, I need to multiply down here. So this is going to give me 7 out of 12 times 8 out of 15. And we can just do that on our calculator, and that will be the chance of getting 2 sunflower seeds, 1 from each. So 7 out of 12 multiplied by 8 out of 15. So that is 14 out of 45. So that is the probability of getting 2 sunflower seeds, one after the other. Okay, next one, question for you snooker fans out there. Ding, as in Ding Junhui, is playing one game of snooker against 2 of his friends, Marco, as in Marco Fu, and Judd, as in Judd Trump. So I think it's quite nice they give actual snooker name to the players. So the probability that the tree diagrams, blah, 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 work out probability that Ding will win both games. Well, once again, to win both games, you have to multiply down this branch. So it'll be 0.6 times 0.9, which is equal to 0.54. Perfect. Okay, work out the probability that Ding will win exactly one of his games. Fine, well, how are we going to win exactly one? Well, the only way to do that is winning and then losing, or losing and then winning. And notice I said the word or there. So in order to do the first branch, we do 0.6 times 0.1, which is equal to 0.06. And the second branch is 0.4 times 0.25, which is 0.1. So because we want either or of these to happen, we add the 2 probabilities together. So the answer would be 0.06 plus 0.1, which is 0.16. So you work out the branches and then you add all the ones that give you success. Okay, another question where they're using the names of famous players. So Magnus, as in Magnus Carlsen, is playing Gary, as in Gary Kasparov. 2 games of chess against each other. So the probability that Magnus beats Gary in any game is 2 out of 9. Okay, so we can put here 2 out of 9 for all of the Magnus wins, because it seems like they're independent. And it says that any draw is 4 out of 9, so we can put 4 out of 9 in here for all these possible draws. And then therefore we've got 2 out of 9 and 4 out of 9. So what's left over is 3 out of 9, because 2 and 4 make 6, and take that away from 9 gives you 3. So that must be the chance of Magnus losing. So we plonk those all in there. Okay, and then we go down here, and it says for each game of chess, the winner gets 2 points, the loser gets 0 points, and then if the game is drawn, we get 1 point each. Work out the probability that after 2 games, Magnus and Gary have the same number of points. Okay, so we need to find the branches which are going to give the same number of points each. So it's going to be if Magnus wins and then loses, they'll have the same points. If the games are drawn, both of them are drawn, they have the same points. And if Magnus loses but then he wins, then he's going to have the same points as his opponent. So what we need to do is we need to multiply along these branches to work out what each probability is. So I will do, well, in fact we could just do this in our head. It makes it easier actually than using the calculator. So 2 ninths times 3 ninths is 6 over 81. 4 ninths times 4 ninths is 16 over 81, just times in the numerators and then times in the denominators. And 3 ninths times 2 ninths is 6 out of 81. And actually keeping the denominators the same makes it easier to add them. So adding them all up is just going to give me 6 plus 16 plus another 6, so 28 out of 81. So we go down here and we say it's 6 out of 81 plus 16 out of 81 plus 6 out of 81, which gives me 28 out of 81. Perfect. Okay, it says Gary and Magnus now play a third game. Work out the probability that after 3 games, Gary and Magnus have the same number of points. Okay, so this is where, when we do 3 games, having a tree diagram becomes a bit unhelpful actually. So what we're going to do is we're just going to figure out all the possibilities. Because if I were to go back up here and start drawing another 3 branches off all 3 branches, it's going to get really messy really quickly. So instead we're going to think about how are they going to be able to tie, basically is what we're saying, or the same number of points. So we could have, of course the easiest one is draw, draw, draw. Or we could have that he wins and then he loses and then he draws. Or he wins, draws, then loses. Or draw, lose, win. Draw, win, lose. Lose, draw, win. And lose, win, draw. So these are the only way that they're going to have the same number of points. Because if there are 2 wins or 2 losses, then they'll never have the same number of points. Now what we could do is we could group these up, because in fact each of these are going to be exactly the same in terms of probability. Now we said before, what was a win? A win was 2 out of 9 and a draw was 4. So this will be 2 out of 9, a loss was 3 out of 9, and then a draw was 4 out of 9. So 2 times 3 times 4 is 24, and that's all going to be out of 9 cubed, which is 729. Now pick any one of these and I guarantee you're going to get the same answer. For example, the next one, 2 out of 9, a draw is 4 out of 9, and the loss is 3 out of 9. So the numerators are going to times to 24 again, and the denominators are going to times to 729. So in fact, all of these together is just simply 6 times by 24 out of 729, because there are 6 possibilities. But that doesn't include the draw, draw, draw. That in itself is separate. There's only one way that can actually happen, and that is that the first game's a draw, so is the second, so is the third. So we have to do this one separately. So that's 64 out of 729. So when we add up, the total probability is going to be the 64 out of 729 plus 6 lots of 24 out of 729. So we could do that on our calculator. Just to save time, I'll just do the numerator part. So 64 and then 6 times 24. That's going to give us all the numerator. So that is 208 over the common denominator of 729. Perfect. Okay, next question. We've got 2 races happening. The probability that she wins the first race is 0.7, so 0.3 she won't. Probability she wins the second race is 0.4, so 0.6 she won't. And it says they're independent, which means the first race doesn't affect the probabilities of the second, so the second races branches are going to be exactly the same as each other. Work out the probability that she wins exactly one of the two races. Okay, so we've done a question like this already. You times those, because that's winning one, and that is the other way you can win one. And we add up anything which gives us success. So this branch here gives us success, and so does this branch. So this will be 0.42, and that will be 0.12. So add them together gives 0.54. Okay, she's now going to take part in a third race. If she wins both of the first two races, the probability she'll win the third is 0.6. If she wins exactly one of the first two races, the probability she wins the third is 0.3. Work out the probability that she will win exactly two of the three races. Right, so that will happen if she wins two at the start and then she loses one. That will give her exactly 2 wins. The other way of doing it is if she wins, she has one win at the start and then she wins again. And if she has no wins at the start from the first two, then she can't have 2 wins overall. So these are the only ways this is going to happen. Now the probability of a double win at the start is this branch here. That is 0.7 times 0.4. So 0.7 times 0.4. So that's the chance of a double win at the start, which we've just worked out. And then she needs to lose her third race in order to win exactly 2. And if she does win her first 2, the probability that she'll win the third race is 0.6. So the probability she'll lose the third race is 0.4. So this will give us one way of her winning 2 races. So we'll just quickly work that out. And that is 14 over 125. Now, the chance she wins exactly 1 from her first 2, well, we've actually already worked that out. It's this. That was her winning exactly 1 from her first 2. So there's no point us doing any more work that we need to, so let's just use that as the chance that she's already won 1 exactly from her first 2. So to make it 2 out of 3, she needs to win another 1. And it says here that if she does win 1 out of the first 2, then the chance she'll win the third is 0.3. So we have to times this by 0.3. So we do 0.54, whoops, multiplied by 0.3. And we get 81 over 500. We add these two together because these are the 2 ways in which we can get success, the only 2 ways. So we add that to this, and that gives us our answer of 137 over 500. Bosh. Okay, next question. We've got a box containing 15 counters. We've got red, we've got green, and we've got the rest are yellow. Nicholas takes at random a counter from the box and writes down the colour of his counter. He puts the counter back into the box. Okay. Then Sasha takes a random counter from the box and writes down the colour of her counter. Work out the probability that the counters taken by them are both the same. Fine. So because we put them back, it means the probabilities are going to stay the same. So the probability of a double red is first off 4 out of 15, and then 4 out of 15 again, because the counters were put back, so the probability is reset. The probability of a double green is 5 out of 15. Again, it's put back, so it's reset. And the probability of a double yellow, well, how many yellows are there? There's 9 non-yellows, which means there must be 6 yellows. So we can work out each of these. In fact, we don't even need to really use our calculator here because it's just square numbers. So 16 over 225, 25 over 225, and 36 over 225. So either of these things will give us the success that we need in having the same colour. So we just need to add them up. And the denominators are the same, so we can just literally just add the numerators to get 77. So it's 77 out of 225. Okay, right, on to the tough questions that use algebra. So, lots to do here. It says a bag contains n beads, 6 of the beads are red and the rest are blue. Okay, so first off, what I suggest you do is you say that the total is equal to n. The number of reds is equal to 6, and the number of blues is equal to, well, there's only reds or blues, so it's the total minus the number of reds. Okay, now we've got that set up perfectly. It then says we're going to take 2 from the bag, and the probability that the 2 bags will be the same colour is equal to this. So we've got to think of a tree diagram that goes like so. And we can have red, red, or red, blue, or we can have blue, red, or blue, blue. Now the ones we're looking at are the same colour, so red, red, and blue, blue. Now what's the chance of getting a red? It's 6. There are 6 reds out of the total n. Now once I take a red out, there are only 5 left for the next pick, and there are only n minus 1 counters left in the bag because you've taken one out. Now if I was going to get a blue straight away, what would be the number of blues out of the total number of counters? And then if I've taken a blue out, there will now be n minus 7 blues. There'll be 1 less than there was before, and the number in total would have gone down to n minus 1 in the bag. So, following our rules for probability trees, if we want to work out a branch, we just multiply along. So the probability of getting a red red will be 30 times the numerators, and then the denominators will times to get n minus 1. So we just times the 2 fractions together, we get this. Or, the other way we get success is we times these ones, because we want the same colour. So there are 2 ways of doing it, so there's 2 different branches. So we add the 2 possibilities to get the overall probability, which we're told is 9 over 17. Okay, perfect. Right, now I'm going to expand the top. So I'm going to I'll do the double bracket here first. I'll get n squared, I'll get a minus 6n, and we'll get a minus 7n. So that makes a minus 13n. And we'll also get plus 42, and we'll have the plus 30 from over here. And that's all over n minus 1. Now 42 plus 30 is 72. So I can get rid of that, and I can write 72 here. Just saving a bit of time just to keep the video length down a bit. Okay, we're going to multiply now both sides by 17, which will cancel out the 17 on the bottom here. And this top line will be multiplied by 17. Okay, and then next what we're going to do, so only the top is times by 17, of course, because you only multiply the numerator when you multiply a fraction. Now we're going to multiply both sides by n minus 1. So that n minus 1 is going to come up and multiply over to this side like that. So we'll get 17 lots of n squared minus 13 plus 72 is equal to 9n minus 1. So just multiplying both sides by n minus 1, n minus 1, and it will cancel out that denominator, and it will come up to this side. Okay, so now we're time to expand, and then we're going to solve this quadratic. Not super duper hot on my 17 times table. Minus 2, 2, 1, and then also 17 multiplied by 72 is plus 1, 2, 2, 4. And that's equal to n squared minus 9n. Minus 9 squared from both sides, and add 9n to both sides. I really don't want to make a mistake here, so I'm just embarrassingly using a calculator to add on 9 to minus 221. Oh, that should have been an n. Forgive me. Minus 212n, and then plus 1224, and that's equal to 0. Perfect. Can we divide this all by 8? I can't divide that by 8, but I can divide it by 4. So we get 2n squared minus 53n plus whatever this is divided by 4. So 306 is equal to 0. Okay, now this probably does factorise because we're going to get a whole number for n, because it has to be a whole number. But I can't see how I'd be able to do this, even in an exam as well. So what I'd want to do then is use the quadratic formula. So it'd be minus b, and again b is this term here, and then plus minus the square root of b squared, which is minus 53 all squared, like that, minus 4 multiplied by a, which is 2, multiplied by 306, which is c, all over 2 lots of a, which is 2. Okay, so now you can do that on your calculator. Okay, you see I've put that in there, so that gives us n is equal to 18. Or if we change the plus here into a minus, then we get the other answer, which is 17 over 2. So let's quickly see what the question asks me. It says find the value of n. So this is the correct answer because n obviously can't be a fraction. It has to be a whole number because it represents the number of beads. So we're good. Okay, so another question very similar to the last one, but a bit trickier. So she has a box containing n pens. So what I'll do once again is I'll write total is equal to n. There are only black and red pens in the box. The number of black pens in the box is 3 more than the number of red pens. Fine. So let's go with the smallest amount. And black is 3 more than red. So let's call red x. That means that black is equal to x plus 3. And then let's not call the total n. Let's call the total, well, what the total is, add the two together, is 2x plus 3. Okay, and now it says the probability that she will take a black pen followed by a red pen is 9 over 35. So important, the followed is highlighted there because just taking a black and a red could be a red and a black or black and a red, but this is specifically one branch from the tree diagram, and that branch goes black and then red. So the chance of getting a black would be x over plus 3 over the total, which is 2x plus 3. Now, to get a red, there are still going to be x reds left over because you've already taken a black out, but the number in the box will have gone down by 1 because you have taken 1 pen out. So the second one will be over x plus 2. Okay. Now it's saying that the probability of that branch specifically, so when I times these two fractions together, I will get this like this. And that will equal 9 over 35. Okay, we're going to cross multiply. So I'm going to multiply both sides by the denominators. So in doing so, the denominator on the right is going to jump over and multiply by the numerator over here. And the denominator on the left is going to jump over and multiply by the numerator over here. So just a nice nifty algebraic trick there to speed things up. And now it's just a process of expanding this out, simplifying down, and then solving the quadratic. So just making sure I'm not trying to make a mistake here. So I won't do this in one. I'll just multiply this out. So 2x squared plus 4x and plus a 6x makes plus 10x, and then plus 6. Can't divide through by any factors, so let's just expand this out. So 36x squared plus 90x plus 54. Let's bring all the terms over to this side, because when you take away 35x squared, you're going to be left with just x squared. And when you take away 105 from 90, you're left with minus 15. And then plus 54. So therefore, this can factorise to minus 6 and minus 9, because minus 6 and minus 9 times to make 54, and they add to make minus 15. So x is either equal to 6 or x is equal to 9. But read the question, so important. We want the total possible values of n. N is the total in the box, and the total in the box is 2x plus 3. So n equals 2x plus 3. So n equals either 2 times 6 plus 3, which is 15, or 2 times 9 plus 3, which is 21. I hope you enjoyed that. See you in the next one. Bye for now.